So let us solve the problems from the review for the third exam. So the first several problems just ask you to apply the formulas that you studied. The first question is about sum or different identity for sine. You need to represent the given angle, this time 165 degrees, as a sum or difference of two angles that can be found on the unit circle. Two special angles. Here we can use 120 and 45 degrees and then apply the formula for sine of a sum. Sine of the first angle times cosine of the second angle plus cosine of the first times sine of the second. Then you substitute the values of the angles and you're done. In the next problem, you need to apply half angle identity. So it means that the given angle should be represented as a half of another angle, 210 over 2. So then cosine of 105 degrees can be written as cosine of 210 degrees over 2. And we use the formula just plus minus square root of 1 plus cosine 210 over 2. So if you look at the unit circle, 210 is in the third quadrant. The reference angle is 30 degrees. The cosine is negative square root of 3 over 2. And to choose plus or minus here, we also look at the unit circle. 105 is greater than 90, so it's in the second quadrant. The cosine must be negative, so we choose negative sign and substitute 1 minus square root of 3 over 2 divided by 2. Okay, we want to rid off of the small denominator 2. For this, we multiply by 2 numerator and denominator of this big fraction and receive negative square root of 2 minus square root of 3 in the numerator and square root of 4, which is 2, in the denominator. Next one, tangent of a sum. Here we also just substituted the values into the formula. Tan of a sum is sum of two tangents, tan of 120 plus tan of theta divided by 1 minus product of tangents. Tan of 120 times tan theta. Okay, 120 is here in the second quadrant. In the second quadrant, cosine is negative, sine is positive, so the fraction will be negative, so tangent must be negative. The reference angle is 60 degrees, so the tangent will be negative square root of 3 plus tan theta divided by 1 minus negative square root of 3 minus times minus is plus tangent theta. Given that cosine 2 theta is 3 over 4 and quadrant 2, find the value of sine of theta. Here we can also use a half angle identity. This time for sine. Sine theta equals positive negative square root of 1 minus cosine 2 theta over 2. Notice that in the identity for sine, we have a minus under the square root. In the identity for cosine, we have a plus under the square root. Let us choose the sine. Since theta is in quadrant 2, sine must be positive. So let us substitute cosine of 2 theta. 1 minus 3/4 divided by 2. And we repeat the same procedure. We want to read off of this denominator times 4 times 4. So in the numerator we have them 4 minus 3, in denominator 8. 1 over square root of 8. Square root of 8 can be written as 2 times square root of 2, because 8 is 2 times 2 times 2. And we want to remove square root from the denominator to rationalize the denominator. So multiply by square root of 2 over 2, and we receive square root of 2 over 4. Next one, solve the equation for y. So first let us isolate the function on the trigonometric function on the left, dividing by 3 on the left and on the right. Then sine inverse of y over 4 equals negative pi over 3. Then you can use definition of inverse function, or we can say that let us act with the inverse function with sine on the left and on the right of this equation. Inverse function, sine and inverse sine cancel out, and we receive y over 4 equals sine of negative pi over 3. Look at the unit circle, negative pi over 3 is here. Reference angle 60 degrees, so the sine is negative square root of 3 over 2. So y over 4 equals negative square root of 3 over 2. To solve for y, let us multiply by 4 on the left and on the right. And we receive that y equals negative 2 square root of 3. Next one, double angle identity. Here you need to recognize a formula. We have one forms for the sine of double angle and 3 different forms for cosine of a double angle. This is one of the form for cosine of double angle. So we can write that it is cosine of 2 times pi over 12. So cosine of pi over 6. Solve the equation for x over the interval. So this is an equation for half angle. You can easily find solutions on the unit circle. On one rotation, we have usually 2 solutions. Cosine is negative in the second and in the third quadrant. So we have these 2 angles, but these 2 solutions are for x over 2. So x over 2 can be equal 5 pi over 6 or 7 pi over 6. So if you multiply by 2, you will get x equals 5 pi over 3 and x equal 7 pi over 3. But 7 pi over 3 is greater than 2 pi. So we don't take this solution because it's beyond the given interval. Find the value of cosine of the smallest angle in the triangle with the given sides. Okay, we need to write the law of cosines. For the given angle, so the smallest side is 2, so the smallest angle will be angle B. To write the law of cosines for B, so B squared equals A squared plus C squared minus 2AC cosine B, and substitute the values. 4 equals 25 plus 16 minus 2 times 5 times 4 times cosine B. So 4 equals 41 minus 40 cosine B. Subtract 41 from the left and from the right. Negative 37 equals negative 40 cosine B. And cosine B equals 37 over 40. The law of sines. So the last 6 problem with 2 points each. So 1 point for submitting the right answer, second point for showing the work in the shown work. You show the formulas that you use and show how you get this solution. Okay, here we have side B, side A, and angle A. We write the law of sines for sine B. So I'm going to solve it for the sine. That's why I write the form of law of sines with sines in the numerator. Sine B over B, sine A over A. So you can multiply times B on the left and on the right. So sine B equals B times sine of A divided by A. So 4 times square root of 2 over 2 over 5. 2 square root of 2 over 5. Next one, solve the equation for theta in the interval from 0 to 360. Here you can see a form of a double-ended identity. That's why let us write 8 as 4 times 2. 2 times sine theta cosine theta is sine of 2 theta. And now we divide by 4 on the left and on the right to isolate the trigonometric function. So sine 2 theta equals negative 1/2. So sine equals negative 1/2 in 2 places on the unit circle for 210 degrees and 330 degrees. But here we also have a change in interval. So this is for 2 theta. And theta is in the interval from 0 to 360. If you multiply this equation by 2, you will get an equation for 2 theta. 2 theta must be considered on the interval from 0 to 720 degrees. So we must consider 2 values for each terminal side. So 210 and 210 plus 360. 330 and 330 plus 260. So 2 theta equals 210, 210 plus 360, 330, and 330 plus 360. Divide by 2. So theta is 105. 105 plus 180, 165, and 165 plus 180. So 4 different solutions. In case we have a quadrantal angle with 1 solution, then for 1 theta there will be 2 solutions. Okay. Next one. Find the magnitude of equilibrium of 2 forces. We have the same example on the slides for chapter 7.4. You can look at here. Solve the equation for solutions of interval from 0 to 360 for the equation cosine x, cotangent x equals negative cosine x. Let us collect all the terms on the left. So cosine x, cotangent x, plus cosine x equals 0. I have added cosine x to the left and to the right. Okay, now we can factor out cosine x. Cosine x, cotangent x plus 1 equals 0. Now we apply zero factor properties. So if two factors, well, if a product of two factors is equal to 0, then each factor can be equal to 0. Cosine x equals 0 or cotangent x plus 1 equals 0 or cotangent x equals negative 1. So cosine x equals 0 on the y-axis and cotangent is negative 1 in the middle of the second quadrant and in the middle of the fourth quadrant. So we have four solutions for this equation. Given magnitudes and direction angles of two position vectors, so it means the initial points are at the origin, find the dot product using two methods. First, using the angle between the vectors, then the dot product u dot v is the magnitude, the product of magnitudes, 10 times 20, 200 times cosine of the angle between them. So we have 30 and 45, the difference 45 minus 30, 15 degrees. You just need to submit this. You don't need to solve to find the value of cosine. Just use this formula and the answers look approximately like this. For the second one, find horizontal and vertical components of the vectors. So the first vector, vector v, the first component, x component is at 10 times cosine 45. Second component is 10 times sine of 45 degrees. So sine and cosine are both square root of 2 over 2, right? So we have 5 square root of 2 and 5 square root of 2. For the second vector, we have 20 times cosine and 20 times sine. So we have 10 cosine of 30 squares of 3 over 2 and 10. So 20 times 1/2 is 10. Then the dot product u dot v is the product of x components. 5 square root of 2 times 10 square root of 3, so 50 square root of 6 plus product of y components. 10 times 5 square root of 2, 50 square root of 2. Okay. If the angles are not in the first quadrant, then some of the components can be negative. Okay, tangent of secant of inverse of u. Let us represent secant inverse as an angle. So such as secant A equals u. Secant is 1 over cosine, so using x, y, and r, secant will be r over x. Let us make a sketch for this angle. It must have r over x equal u. So let us take r equal u and x equal 1. Then y will be hypotenuse squared minus x squared. So u squared minus 1. We need to find the value of tangent. tan of A, right? Tangent is opposite of adjacent, so it will be square root of u squared minus 1 divided by 1, right? And there will be a bonus question, sound like sine inverse of x equals cosine inverse of, for example, 1/6. And we can do the same thing as we did in this problem. We can call this angle A. Using the definition, it must be the angle such as cosine A equals 1/6. So we can take a triangle with the hypotenuse 6 and the adjacent side 1. Then the cosine is 1/6. And the opposite side will be 36 minus 1 square root of 35. Then this is the same angle A. Sine A must be equal to x. So x equals square root of 35/6. Okay, that's all. Thank you. If you have any questions, just email me. Okay.